Hello, good afternoon. We are going to start matrices SAQs. So matrices, I think LAQ is completed in matrices. Voice still not audible. Voice not audible. तो matrices में SAQs करना है देखो. तो first SAQ ले लो. One SAQ will come under matrices. Okay, question is, if I matrix is given, E matrix is given, then we have to prove this. This LHS is equal to RHS ये prove करना है. तो first take the LHS. LHS में क्या है देखो, AI plus B whole cube है ना. तो first find A into I plus B into E. So this is small b actually. A into I plus B into E. First let's find this. So what is A into I matrix given? 1 0 0 1 plus B into E matrix. What is E matrix given? What is E matrix? 0 1 0 0. Okay. So this equals to A matrix से स्केलर नंबर से मल्टीप्लाई करना में तो डायरेक्टली सबको पूरे एलिमेंट्स को इनटू कर सकते हैं. A into 1 is A into 0 is 0, A into 0 is 0, A into 1 is A, plus multiply with B, B into 0, multiply B with all elements of the matrix. B into 0, B, B into 1 is B, B into 0, 0, B into 0, 0. Then add these two corresponding matrices. Corresponding elements को add कर लेते जाओ पूरे. So A plus 0 is A. Next 0 plus B is B. 0 plus 0 is 0. A plus 0 is A. Now this we got AI plus BE value. Next do AI plus BE whole cube. How you will find AI plus BE whole cube? Please remember AI plus BE is AB0A now. So take LHS. What is LHS? AI plus B into E whole cube. So what is AI plus BE whole cube? This is nothing but AI plus B is how much we got? AB0A now. So multiply thrice this matrix. AB0A. AB0A. So multiply this 3 times. AB0A into AB0A into AB0A. So A plus B matrix, what we got previously? AB0A. So multiply this thrice. So first what I will do multiplication of these two matrices first. Then I will multiply this matrix. So multiply this. How is the matrix multiplication? Corresponding row, corresponding column multiply करो. So how you will do? Corresponding row 1, column 1. You multiply correspondingly. A into A is A square. B into 0 is 0. So correspondingly, right? You multiply like this and put it on writing the elements. So first A into A is A square plus B into 0 is 0. 0. In the same way, multiply A with B into A. Now you multiply these two matrices. Now multiply these two. Corresponding row, corresponding element, put it here. So how you will do the multiplication? A into B is AB plus B into A is AB. Okay, done. In the same way, multiply this row and this column. So 0 into A is 0 plus A into 0 is 0. Again, multiply this row and this column. 0 into B is 0 plus A into A is A square. So this multiplication is done. ये दोनों matrices का multiplication कर लिया अभी. तो इसको सॉल्व करके फिर फाइनली इससे भी मल्टीप्लाई करेंगे a b 0 a से. Okay, this equals to a square plus 0 is a square, ab plus ab, how much it is? 2ab. 0 plus 0 is 0, 0 plus a square is a square. So multiply this with a b 0 a. Multiplication procedure of two matrices is same as I told before. Say corresponding ये row और corresponding ये column को multiply करके या first element में लिखो a11 first row first column में. So how you will write? Multiply this correspondingly. A square into a cube. Okay, a square into a is a cube plus 2ab into 0 is 0. So first row first column को into करके यहाँ लिख दो. In the same way first row second column multiply this. A square into b is a square b plus 2ab into a, 2ab into a, 2a square b. Okay, next in the same way second row first column you will write here. Second row last column you will write here. Okay, second row and first column 0 into a is 0 plus a square into 0 is 0. Next multiply second row and last column 0 into b is 0 plus a square into a is a cube. Okay, this finally matrix is this is equal to a square plus 0 is a cube plus 0 is a cube, a square b plus 2a square b. How many a square b? 3a square b. 0 plus 0 is 0, 0 plus a cube is a cube. So this is the matrix we got, LHS we got. AI plus BE whole cube value we got it as a cube 3a square b 0 a cube. Now consider RHS. LHS value I got now. This LHS value I got. This value we got. Next we will find this value and check if they are equal or not. So that means it will definitely be equal. So next a cube I plus 3a square b into E. Consider RHS now. So what is RHS? A cube I plus 3a square b into E. A cube into I plus 3a square b into E. So let's check its value is coming this or not. Obviously, it should come this only. Okay. So a cube into I. What is I matrix? Identity matrix 1001. Okay. I matrix is given in question as well. What is I? 1001. Next check E matrix 0100. E matrix is 0100 plus 3a square b into E matrix is 0100. Is it correct? 0100. Next multiply these two. A cube. Multiply to each element. A cube into 1, a cube plus a cube into 0, 0. Next a cube into 0, 0. A cube into 1, a cube. Okay. Next multiply this 3a square b into 0, 0. 3a square b into 1, 3a square b. 3a square b into 0, 0. 3a square b into 0, 0. Now add these two matrices correspondingly. First element add karo. First second element ये element add करो, ये element correspondingly add करो. Add these two elements. Okay. So a cube plus 0 is a cube. Now 0 plus 3a square b is 3a square b. And 0 plus 0 is 0. A cube plus 0 is a cube. Now check these two. Are these two equal? From 1 and 2. This is 1 we got, 1 value. A plus BE whole cube value, we got it as a cube 3a square b 0 a cube. In the same way, RHS value I have taken, I have found, and its value is also same. So from 1 and 2, so put the conclusion from 1 and 2. So what is the LHS? AI plus BE whole cube is equal to a cube into I plus 3a square b into E. Now under SCQ second question. So question is, if A is equal to matrix given 3 by 3 matrix is given 3 minus 3 4 2 minus 3 4 0 minus 1 1. Okay. If A matrix is given, then show that we have to prove A inverse is equal to A cube. So before showing this value, before showing this, so what we should know the concept of A inverse. So from the definition of inverse, if I prove this A into A cube, if I multiply A into A cube is equal to A cube into A. If I prove this as is equal to I, then I can directly say from the definition of inverse of matrix, ये एक दूसरे के इनवर्स होते हैं ना, A inverse is equal to A cube होता, या नहीं बोले तो A cube is equal to A inverse होता, A cube whole inverse is equal to A होता. So whenever A into A cube is equal to A cube into A is equal to I, then we can say these two matrices are inverse to each other. या नहीं बोले तो suppose take like this, inverse definition is if A into B is equal to B into A is equal to I, then we can directly say A and B are inverse to each other. From the definition of matrices, A and B are inverse to each other. We can say A is equal to B inverse or B inverse is equal to A. You can take anything. Both are inverse to each other. In the same way, what I am going to do here is in this problem, I am not going to find A inverse separately. I am not going to find A cube separately. What you have to do, you just find A to the power of 4 value. Nothing but A into A cube value. You find this. And check if you are getting this value as I, then you can directly say that A is equal to A inverse is equal to A cube from the definition of matrix. So what I am going to find here is I am going to find A into A cube value here. Okay. So these are the definition of this is the definition of inverse of a matrix. So first find A power of to find A power of 4, we need to first find A square value. A into A. A square is nothing but A into A. What is A matrix? 3 minus 3, 4, 2 minus 3, 4, 0 minus 1, 1. This into A. Same 3 minus 3, 4, 2 minus 3, 4, 0 minus 1, 1. So multiply A square first, then we will find A power of 4. First, we will find A square, then we can find A power of 4. To find A power of 4, we multiply A square into A square. So 2 plus 2 is 4 now. So to find A power of 4, we need A square first. So that's why I'm finding A square. So A square into A matrix. कैसे multiply करते हैं? Matrix multiplication. Procedure I said, this row, this column, correspondingly. One element will come here. In the same way, first row, second column, second element will come here. First row, third column, this element will come. In the same way, you goes on finding everything. Okay. So can I write directly here? 3 3 ja 9 minus 3 into 2. 3 2 ja 3 3 ja 9 minus 3 into 2 minus 6. 4 into 0 0. In the same way, first row, second column, you do multiplication correspondingly and add 3 into minus 3 minus 9 minus 3 into minus 3 minus into minus plus 9. 3 3 ja 9. 4 into minus 1 minus 4. In the same way, multiply these two. 3 4 ja 12. Minus 3 into plus 4 minus 12. 4 into 1 plus 4. Okay, plus 12 minus 12 cancel, plus 9 minus 9 cancel. Next, in the same way, multiply this row in this column. 2 3 ja 6 minus 3 2 ja 6 plus 4 into 0 0. In the same way, multiply this row in this column. 2 3 ja 6 minus 6. 2 into minus 3 minus 6 minus 3 into minus 3 minus into minus plus 3 3 ja 9. 4 into minus 1 minus 4. Next, multiply this row and this column. So 2 into 4, 2 4 ja 8 minus 3 into minus 4 minus 12. 4 into 1, 4 1 ja 4 plus 4. Okay, in the same way, multiply this third row and first column and write element here. 0 into 3, 0, minus 1 into 2, minus 2, 1 into 0, 0, plus 0. In the same way, multiply third row and second column. 0 into minus 3, 0, minus 1 into minus 3, minus into minus, plus 1 3 ja 3, 1 into minus 1, minus 1. The same way, first row, third row and last column. So 0 into 4, 0, minus 1 into 4, minus 4, 1 into 1, plus 1. So what is the answer of this finally? 9 minus 6 is 3. And here remains answer is minus 4. And here answer is plus 4. 6 minus 6 is 0. Minus 6 minus 4. How much it is? Minus 10. Minus 10 plus 9. Minus 1. So 8 plus 4 is 12. 12 minus 12. All cancel. 8 plus 4 is 12. 12 minus 12 is 0. 0 here. Next, 0 minus 2 minus 0. Minus 2 remains. 3 minus 1 value is 2. And minus 4 plus 1 value is minus 3. So this we got a square value. Then again, we are going to find a power of 4. So a power of 4, how you will find a power of 4 value? So to find a power of 4 value, so a power of 4 value is a square into a square now. So multiply these two matrices again twice. So a square matrix is how much we got? 3 minus 4, 4, 0, minus 1, 0, minus 2, 2, minus 3. So multiply this twice, a square value. 3 minus 4, 4, 0, minus 1, 0, minus 2, 2, minus 3. This a square into another a square. So 3 minus 4, 4, 0, minus 1, 0, minus 2, 2, minus 3. So multiply these two matrices again. Same procedure. Corresponding row, corresponding column. Multiply this and this and put it here. Procedure is same as we did previously. So first row और first column को multiply करो correspondingly. बीच में add करके यहाँ पे लिख दो. Okay, whatever is the element. So multiply. So 3 3 ja 9, minus 4 into 0, minus 0, 4 into minus 2, minus 8, 4 2 ja 8. Again, first row, second column. 3 4 ja 12, minus 12, minus 4 into minus 1, plus 4. Minus into minus plus हो जाता, 4 1 ja 4. फिर 4 2 ja 8, plus 8. In the same way, this row, this column. 3 into 4, 3 4 ja 12, minus 4 into 0, minus 0, 4 into minus 3, minus 12, 4 3 ja 12, minus 12. In the same way, multiply this row and this column. So, now multiply correspondingly second row, first column, 0 into 3, 0, minus 1 into 0, minus 0, 0 into minus 2, again 0 it is. Next, second row, second column, 0 into minus 4, 0, minus 1 into minus 1, plus 1 it will be, 0 into anything, 0, plus 0. Next, multiply correspondingly, 0 into 4, 0, minus 1 into 0, plus 0. So 0 into minus 3, again 0 it is. So now last third row and first column, minus 2 into 3, minus 2 3 ja, minus 6, 2 into 0, 0 plus 0, minus 3 into minus 2, minus into minus plus 3 2 ja 6. Again multiply third row and second column, minus 2 into minus 4, minus into minus plus 2 4 ja 8, 2 into minus 1, minus 2, so minus 3 into plus 2, minus into plus minus 3 2 ja 6. In the same way, correspondingly, last row, last column, multiply and add correspondingly. Minus 2 into 4, minus 8, 2 into 0, 0, plus 0, minus 3 into minus 9, minus into minus, plus 3 3 ja 9. Now operate all this. So this equals what? So 9 minus 8 plus 1. 8 plus 4, 12 na. Plus 12 minus 12 cancel, 0. Okay, 12 minus 12 plus 12 minus 12 cancel, 0. So here it is totally 0. This one is 0. Next, 0 plus 1 plus 0 is 1. So this is 0 actually. Next, 0 plus 0 plus 0 is 0. Next, last row, minus 6 plus 6 cancel. 6 minus 6, 0. Minus 6 minus 2, minus 8 now. Minus 8 plus 8 cancel. Answer is 0 here. Finally, 9 minus 8 plus 1. So what it is, which matrix it is? Identity matrix, I, 3 by 3 matrix. So a power of 4 value you are getting as I now. So a power of 4 value you got it as I. Nothing but what? A into A cube. A power 4 can be written as A into A cube is equal to I. So can we write like this? A square into A square is also I. A into A cube is also I. So what can you say from the definition of inverse of a matrix? At the outset, I said whenever A into B is equal to B into A is equal to I, then A and B are inverse to each other. So here we got the result as A into A cube is equal to I. Then A is inverse of A cube. Yeah, A cube is inverse of A. So therefore, right conclusion, A inverse is equal to A cube. How did you write from definition of inverse of a matrix? Okay. Now similar question, SAQ, third SAQ. Question is, if 3A value is equal to, if 3A is equal to matrix given 1, 2, 2, 2, 1, minus 2, minus 2, 2, minus 1. 3A matrix is given, then show that A inverse is equal to A transpose. Again, same method, same we will use inverse inverse definition, inverse of two matrices. How you will find? Suppose मैं यहाँ पे क्या proof करता हूँ मैं same यहाँ पे, if A into B, same concept, A into B is equal to B into A is equal to I. Then from definition of inverse of a matrix, what we can say? A and B are inverse to each other. That means what? A inverse is equal to B or B inverse is equal to A. From the definition of inverse of a matrix. In the same way, what I am going to prove here is, I will not find A inverse separately, A transpose separately. A inverse itself is a lengthy procedure to find A inverse. Instead of that, what I will do, I will just multiply A and A transpose. Multiply A and A transpose. If its answer is I, then we can say A inverse is equal to A transpose from the definition of inverse of a matrix. So simple procedure, don't do A inverse separately, A transpose separately, and don't check the result. Just simply multiply A into A transpose. If it is I, then we can say A inverse is equal to A transpose. So I can't take A subject. I can't make A subject here, because if I make A subject, 3 will divide each element. So it will be a complex multiplication. Every element will be in fraction. So don't do that. What I will do first here is, I will multiply 3A. So first check 3A into 3A transpose. First I will multiply these two. Okay. So what will be the answer? So before this, first check what is 3A transpose value. 3 into A whole transpose value. स्लाइड कर रहा हूँ, मैं नहीं कर सकता. स्लाइड नहीं कर सकते. नहीं, वो स्क्रीन को स्लाइड कर रहा हूँ. स्क्रीन को स्लाइड कर. अच्छा. Here, what I will find first we will find 3A whole transpose. So from the transpose property, if transpose comes upon a number, it doesn't intersect, it doesn't interfere with the transpose, just it is equal to 3 into A transpose. So what is 3 into? So 3 into A whole transpose. So 3 it's a scalar. It doesn't affect with transport. So 3 take outside, 3 into A transpose. So what is A transpose? A transpose. So how you will find A transpose? Simply you interchange this row, make column 1 as row 1, column 2 as row 2, and column 3 as row 3. So this will be transpose of A transpose. So how you will find A transpose means simply replace 1, 2, minus 1. It's column 1 now. I am changing this as 1, 2, minus 2. I am changing column 1 as row 1 and column 2 as row 2. So what is column 2? 2, 1, 2. And what is column 3? 2, minus 2, minus 1. Make it as row 3. 2, minus 2, minus 1. This is transpose of A. So this I did, and so keep it aside like this. So now consider 3A into 3A whole transpose. So what is this value? So what is 3A matrix given? Don't divide by 3. So if we divide by 3, then it will be a complex again. Okay, multiply 3A into 3A whole transpose. What is 3A matrix? 1, 2, 2, 2, 1, minus 2, minus 2, 2, minus 1. 3A whole transpose. So I am multiplying A into A transpose again here. So A transpose क्या है? 1, 2, minus 2, 2, 1, 2, 2, minus 2, minus 1. So multiply these two matrices. So here in RHS 3 3 ja 9. A into A transpose you multiply A into A transpose. This is equal to multiply these two matrices correspondingly. So how you will do multiplication? Same procedure. Horizontal, one row, one column. Multiply like this. So 1 into 1, 1 into 1, 1 plus 2 2 ja 4, 2 2 ja 4. So again multiply first row and second column. 1 into 2, 2, 2 1 ja 2 plus into minus minus 2 2 ja 4 minus 4. Again multiply first row and third column. 1 into minus 2, 1 into minus 2 plus 2 2 ja plus 4. So 2 into minus 1 minus 2. Again in the same way multiply second row and first column. So 2 1 ja 2 plus 1 into 2 2 minus 2 into plus 2 minus 4. 2 2 ja 4 minus 4. Again multiply second row second column. 2 2 ja 4, 1 into 1 1, minus 2 into minus 2, minus into minus plus 2 2 ja 4. Again multiply second row and third column. 2 into minus 2 minus 4, 1 into 2 plus 2. Okay, minus 2 into minus 1, minus into minus plus 2 1 ja 2. Again multiply third row first column. Minus 2 into plus 1 minus 2, 2 into ja 4 plus 4, minus 1 into plus 2 minus 2. Again multiply third row and second column and write here minus 2 into plus 2 minus 4, 2 1 ja 2 plus 2, minus 1 into minus 2 minus into minus plus 2 1 ja 2. Again in the same way multiply third row and last column. So minus 2 into minus 2 minus into minus plus 2 2 ja 4 plus 4. Okay, so plus 2 2 ja plus 4 and minus 1 into minus 1 it is plus 1. So finally what is the matrix you got? This equals 4 plus 4 plus 1 9. Finally matrix is 4 plus 4 plus 1 is 9. So 2 plus 2 4 plus 4 minus 4 0. Again minus 2 is minus 4. Minus 4 plus 4 cancel. Here also 0. Again here 2 plus 2 is 4. 4 minus 4 0. This element is also 0. So 4 plus 4 8. 8 plus 1 9. Here 9 we get. Next 2 plus 2 is 4 plus 4 minus 4 cancel. Here again 0. Next here also minus 2 minus 2 minus 4 plus 4 cancel. Answer is 0 here. So same 2 plus 2 4, 4 minus 4 is 0. Finally 4 plus 1 is 9. So in this matrix, can I take 9 as common? If I take 9 as common, what is the matrix again? 1 0 0 0 1 0 0 0 1. That is, from all elements I have taken 9 common. So what I got finally, this is equal to 9 into I. So now check here, 9 into A transpose is equal to 9 into I now. So what we got finally here, 9 into A transpose. This value we got it as 9 into I. So 9 cancel. So finally A into A transpose is how much? This is equal to I. So from the definition of inverse of a matrix, what we can say, A transpose are inverse to each other. Means what? A inverse is equal to A transpose. From the definition of inverse of a matrix. So this is the result we got. Now, next SAQ. Next SAQ, fourth SAQ. Show that determinant of 1A square, 1B square, and 1C square. Determinant of this is equal to A minus B into B minus C into C minus A. So again, same here, we have to prove this. This LHS is equal to RHS. So consider the LHS determinant. Using determinant properties, we are going to prove LHS is equal to RHS. So first take LHS here. So LHS क्या है? Determinant of 1A square, 1B square, 1C square. So in this, what I am going to do, okay, in this what I am going to do, I am doing row transformations here. So in determinant, we can use determinant all properties. So what I am going to do is, I am changing R2, this is R1 first row, R2 second row, R3 third row. I am changing R2 changes to R2 minus R1. So subtract this minus this minus this minus this, and put it in second row. In the same way, I am doing R3 changes to R3 minus R1. Okay. So first row as it is, no disturbance, 1A square. In second row, first row is 1A square. In second row, R2 minus R1 now. So R2 minus R1, 1 minus 1, 0. This B minus A, R2 minus R1 right here. R2 changes to R2 minus R1, B minus A. Same R3 changes to R3 minus R1, B square minus A square here. Next, in the same way, R3 changes to R3 minus R1 now. So subtract this row and this row correspondingly. So 1 minus 1 is 0, C minus A. Next, C square minus A square, C square minus A square. So next again, here I am going to change. I am going to use B square minus A square can be written as B plus A into B minus A, right? In the same way, C square minus A square can be written as C plus A into C minus A. So change these two. So again, LHS only I am finding determinant of 1A square, and here second row is 0, B minus A. Here B square minus A square can be written as B minus A into B plus A minus B into A minus B formula, A square minus B square. So B square minus A square can be written as B minus A into B plus A. So this should be B plus A. B minus A into B plus A. Next, in the same way, third row is 0, C minus A. This can be written as C square minus A square can be written as C minus A into C plus A. So this changes to C minus A into C plus A. Okay. Now again using determinant property, from the determinant property b minus a पूरे जगह है ना, 0 को 0 into b minus a लिख सकते हैं. So here b minus a b minus a b minus a, from the row 2 I am taking b minus a common. Okay. In the same way from row 3, observe here we have c minus a, here we have c minus a. 0 is nothing but 0 into c minus a now. So from this R3 I am taking c minus a common. So what is the final? 1a square. Next 0 b minus a taken out. So it will be 1 b minus a taken out. What is the remaining? B plus a. Same here also 0 c minus a taken out, 1 c minus a taken common, c plus a. So this is the final determinant. Now here again we have determinant property. If suppose in a row or column, if two zeros are there like this, so you can neglect this row and this column. You can neglect this row and this column. You just do the determinant of 1 into this matrix, 1 into determinant of this matrix. So from the determinant property, if two rows are there, if two zeros are there in any row or column, you just exclude this row and corresponding column like this. So after that, you just do the determinant of 1 into this determinant. Okay. So this equals b minus a into c minus a into what we have to do? 1 into determinant of this matrix, this 2 by 2 matrix. So 1 into c plus a minus 1 into b plus a. So minus of b plus a होता. Correct है? 1 into c plus a, बीच में minus रहता. 1 into b plus a is b plus a. So multiply this again. So this equals to b minus a into c minus a into, so 1 into anything, same thing now. So c plus a as it is, minus 1 into b, minus into plus a, minus a. So plus a minus a cancel. Finally, what we got? B minus a into c minus a into, this is c minus b. So in this, what I am changing is b minus a minus b we have to get now. So what I am doing, if I make it as a minus b, if I interchange like this, minus will come. Always remember, whenever interchange a minus b as b minus a or b minus a as a minus b, whenever you interchange, minus will come out here like this. Okay. This minus, I am using this minus. So use this minus here in this a minus b, b minus c, c minus a. So what I am doing, so this a minus b as it is, a minus b. If you multiply minus here in this minus into c, minus, if you multiply minus here, c minus b will become b minus c. So this becomes as b minus c. So a minus b, b minus c. Third one, c minus a term is as it is. So this is the proof we got. So using determinant property, we found this. Now next question. Question is given as if theta minus phi is equal to pi by 2, then show that cos square theta, cos theta, sin theta, cos theta, sin theta, sin square theta, this matrix into another matrix, cos square phi. So cos phi into sin phi, cos phi into sin phi, cos phi into sin phi. Plus sin square phi. So this equals to 0. ये proof करना है देखो. Next question. Question क्या है? If theta minus phi is condition given as pi by 2, then multiplication of these two matrices is equal to 0 proof karna hai. So how you will same LHS, consider the LHS. In LHS, you have to multiply these two matrices now. Same procedure, matrix multiplication. How you will do? First row, you multiply with corresponding first column. Corresponding elements you multiply cos square theta with cos square phi plus this into this. Okay, multiply and write in first column, first row. So cos square theta into cos square phi is cos square theta into cos square phi. Okay, next plus will come cos theta sin theta into cos phi into sin phi. What it will be? Cos theta sin theta into cos phi sin phi. Cos phi sin phi. Okay, this is first element A11 completed. In the same way, you multiply first row with second column. Correspondingly, you multiply and add these two and write here. So first row, second column. So cos square theta into this cos square theta into cos phi into sin phi. It will be what? Cos square theta into cos phi into sin phi. Okay. Next plus multiply these two correspondingly. Cos theta into sin square phi. So it will be what? Cos theta into sin theta into sin square phi. Okay. In the same way, multiply second row with first column. So correspondingly, इसको into करो plus इसको into करो. So cos theta into sin theta into cos square phi. It will be what? Cos theta into sin theta into cos square phi. Plus multiply these two. Sin square theta into cos phi into sin phi. It will be what? Sin square theta into cos phi into sin phi. Okay. In the same way, multiply second row, second column correspondingly. So cos theta into sin theta into cos phi into sin phi. Multiply as it is. Cos theta into sin theta into cos phi into sin phi. Plus multiply these two. Sin square theta into sin square phi. Sin square theta, sin square phi. Okay. This is the multiplication of these two matrices. Please be careful with multiplication. So after this, what we will do? We are going to take common. Common लो इसमें क्या maximum possible common हो सकता? What we can take maximum common? Cos theta, one cos theta, we can take common here. You see here, one cos theta and one cos theta we can take common from here. In the same way, one cos square phi, one cos phi and one cos phi we can take common here. So take common cos square, one cos theta and one cos phi. Take common from these two. One cos phi. So after we take common, what is the remaining? Cos theta, cos phi. Cos theta into cos phi. Plus one cos theta, one cos phi. We have taken common. Remaining is what? Sin theta into sin phi. Okay. In the same way, take common here also. Same in all four elements. Okay. So what we can take common here? Maximum possible common. Cos theta we can take common again. One sin phi we can take common. Correct? So take cos theta and sin phi common. One cos theta we have taken common and one sin phi I have taken common. So what is cos theta common liye to ek cos theta basta. Again remaining is cos phi. Cos theta into cos phi. And here one cos theta taken common, one sin phi taken common. Here sin theta into sin phi. Same, the same way you take common here as well. Cos theta here also. What we can take common? Max we can take common. One sin theta we can take common. And one cos phi we can take common. So take common these two. So sin theta I am taking common and cos phi. Sin theta and cos phi. After taking common this, what is the remaining here? One cos theta is remaining and one cos phi is remaining. Okay. Plus after taking common, one sin theta is remaining and one sin phi is remaining. Okay. The same way here, take common. What will you take common here? Common possible. One sin theta we can take common from these two. And one sin phi we can take common from these two. So take it common. So sin theta into sin phi. So after taking common this, what is the remaining? Cos theta, cos phi plus cos theta, cos phi remaining here. One sin theta, one sin phi is remaining. Sin theta into sin phi. So what is the formula here? You observe here, after multiplying these two matrices and after taking common, in all elements you can observe cos theta, cos phi plus sin theta, sin phi. This is common everywhere. Cos A, cos B plus sin A, sin B. We have formula here. Cos theta, cos phi plus sin theta, sin phi. Everywhere we are getting this term. Okay, what is this? Cos A, cos B plus sin A, sin B. Cos of A minus B formula. So change this as cos theta into cos phi into this can be written as cos of cos A, cos B plus sin A, sin B. So this is cos of A minus B. Cos A, cos B plus sin A, sin B formula is cos of A minus B. Same here also, cos of theta minus phi. Same cos of theta minus phi come here, here as well as here. So take this as cos phi in cos theta into sin phi, sin phi into cos of theta minus phi. Okay. Here also take common sin theta into cos phi into cos A, cos B plus sin A, sin B, cos of A minus B, theta minus phi. So here also sin theta, sin phi into cos A, cos B plus sin A, sin B, cos of theta minus phi. So what is cos of theta minus phi value? So if we check, so in question condition is given. So in question condition is what? Theta minus phi is equal to pi by 2, condition given. So if we apply cos on both sides, so what will be cos of theta minus phi value? Cos pi by 2. So what is the value of this cos pi by 2? 0. Okay. Cos of theta minus phi value is how much? 0. So here it comes 0, cos of theta minus phi. Where are cos of theta minus phi? So here its value is 0. Here also its value is 0. Here also its value is 0. Here also its value is 0. So 0 into anything 0, 0 into anything 0, 0 into anything 0, 0 into anything 0. So finally the matrix becomes as 0, 0, 0, 0. So which is which matrix? 0 matrix, 0. Be careful with calculations and taking common. Please remember just one thing. Here comes cos of theta minus phi everywhere. Here as well, here as well, here as well, here as well. Cos of theta minus phi will come. Okay. Till here we completed matrices 4 marks questions. Then tomorrow again we will continue next VSAQs in matrices. So we are concluding here 1A matrices completed 4 marks. Next we will start 2B. Okay, thank you.